AI eliminates those jobs, period, full stop. And we already can do that today. So this isn't the future. Now, should we was your question. I will tell you there's not a CIO/CFO, and sometimes they're locked at the hip a little bit, that is going to pay for AI going forward unless they find the savings somewhere else. Money doesn't grow on trees in an enterprise. It could be that it's customer facing and it improved our revenue, right? Improved our advertising, but for back-end systems, nobody's going to pay for Devin if you cannot measure the improvement in coding in some way, or a reduction in hiring new hires that you don't need anymore.
Thanks everybody for joining today. We have Kevin Surace. Kevin's a 30-year AI veteran. He's inventor of the virtual assistant Portico back in the 90s and now leads Appvance.ai. Appvance's Genie digital twin platform autonomously designs and runs millions of regression tests with the goal of eliminating QA costs. He believes foundational models are quickly becoming commodities, and the real mode is specialized stacks of tuned transformers aimed at concrete pain points like software QA. Kevin, thanks so much for coming on the show.
Yeah, happy to be here. Thanks for having me.
Awesome. Why don't we get started? Tell us a little bit about what people did before your solution and what's different with your solution.
Specifically at Appvance, we have focused on software QA, and everyone knows what software bugs are, right? And your typical enterprise has thousands of applications that they manage, update, upgrade, fix stacks on, etc. And all of those have to be tested over and over and over again with regression testing, right? What people have done since the 60s is the majority of it's manual testing. It's just literally teams of people around the world that do that work. It is, of course, it's manual, so it's inconsistent and has all the things that happen in manual. It's costly, it takes time, etc. But it's how we've done it. And then we've had test automation basically since the 90s for about 30% of those regression tests. And that is a very painful process in and of itself, because test automation, either you're writing code, so you've written code for the application, now you have to write code to test the application, or you're recording code with a recorder that have been out since the mid-90s, and they've gotten substantially better. But these are expensive people, more expensive than the manual testers. So whether you're automating or doing manual testing in regression, you quickly end up with hundreds of thousands, if not millions, of regression tests that you have to maintain for the rest of your corporate life, right? People will come into that corporation and die, and only that number gets bigger. So we looked at it and said, we think there's a better way.
Yeah. And are you focused more on application level testing, like coming in through the front end?
Yeah,
or are you
and full end to end.
Are you also doing like white box testing where you're like consuming the code and helping generate, unit tests and regression?
Yeah, no, not unit testing and not source code testing, which is a whole different field, actually. It's actually full end to end. And the reason is, people think of an application, if they're not in our field, they think of an application as, something that runs on the phone or something that is, this one thing. But a typical corporate application is talking to more than 20 back-end systems. So it actually can't practically be tested as an end-to-end test until it's fully connected to those systems, because APIs change and back-end systems change and algorithms change on the back end and. And so there is this sort of end-to-end regression testing that must happen. You really don't know if this change in a back-end system where you updated the API and changed the stack, you don't know if that's going to affect these 50 other systems that use that system, right? Until you go back and test them. And you say, well, we have a set of criteria and a set of business rules and a set of business goals in this application. Do those all still work? Do they come out with the right outcomes? Do they put up the right pop-up box? Do they stop you if you did the wrong thing? Do they come out with the right numbers? Whatever it is, right? And so that's end-to-end regression testing. It probably occupies 80 or 90% of all testing in the industry. It's a very big number. It is a given that if you're developing a new application, you are certainly doing unit testing, you are certainly doing source code testing, you're doing a lot of things. But again, in a regular enterprise, the number of new applications that are being developed is less than 1% of the total application inventory. So it's small in comparison.
Yeah, so you mentioned enterprise a few times. Tell me a little bit about that focus. Does that mean that your target customers are building internal tools for within their enterprise, or are you anyone building a consumer app as well?
It can be consumer. So for example, we have customers who are in the e-commerce space, and they will test their e-commerce application, and they will also test 2,000 other applications that run their corporation, right? So if you look at, for instance, a bank, let's take JP Morgan because they're the largest. They have about 15,000 applications that they maintain and manage today. There's about 10 that face the outside world that consumers might see or businesses might see. All the rest run the company, back end, front end, middleware, everything, right? That they own and maintain. Some of those, obviously, like an ERP system, is SAP, and that was built on the outside. But of course, they've customized it on the inside, so now it's their responsibility for end-to-end testing. But it's 15,000 applications under management and under regression testing on a regular basis.
Got it. So maybe let's dig into the JP Morgan scenario a little bit. So one of the challenges with, manual or automated testing is that it's easy to kind of get light superficial testing, but building up sort of a realistic actual user profile that's gone in and done a bunch of stuff, and now you're going off and using the application, and there's various expectations based on what state you're in. Walk us through, like, in your application. So for example, with the JP Morgan case, JP Morgan, you have to have a real bank account. They have to have like provisions for you to have a fake bot sitting in there actually with an account that can do stuff, and a lot of their stuff actually does stuff, like moves money around. And
that's right.
Right. How do you with all of that?
Yeah. So all major applications have test users, and those test users, we didn't invent that, right? They've had to have test users because remember, these are people who have been testing these applications, some for 10 or 20 years. And so they've got test user accounts and they've got test data, and they have a way to either undo that or make sure that it doesn't actually commit a major transaction, right? Or the transaction's a penny or something like that, right? If they want to test it all the way through. So there are already provisions for that. We don't have to fix that. They already have that. Remember, if I look at any one of those 15,000 JP Morgan applications, there are already regression test suites for them. There are already people doing those tests, and they are already spending more than $1 billion a year doing those tests, right? Across wherever their testers are and test automation is, et cetera, et cetera. So we look at that and say, how can we apply AI to take those people out of those jobs? I'm sorry. That's, that's what we do with AI is we improve productivity, improve visibility, right? So if you want to be funded by a CFO in any AI circumstance, by the way, I don't care if it's marketing tools, if it's dev tools, whatever, ultimately the CFO is going to say, I'll give you a budget for a year, but if I don't see the savings, right, that budget doesn't grow on trees. I got to see that savings in headcount reduction or some other thing, increased customer satisfaction or some other method of measuring. And so that's what we see large corporations and most enterprises look for today in AI. I'll give you the AI budget this year, but in a year, I've got to see more savings than that. What's the ROI? Is it 2x? Is it 3x? Is it 4x? Is it 5x? I got AI and customer support. Okay, who's going to pay for that $1 million a year? Did we take some customer support heads out? No. Well, then forget it. It's budget canceled at the end of the year. So we make no bones about the fact that ultimately this drives headcount reduction. That pays 2x, 3x, 4x, 5x, as much as 10x more than the software in terms of savings.
We'll come back to the potential ethical ramifications of that, because I do want to explore that area more about what actually happens when AI starts taking all these jobs. But for now, let's put a pin in that because I want to understand your approach a little bit. So let's say that you start at the JP Morgan scenario, you fire up your app for the first time. What does the configuration process look like?
Sure.
Walk us through. So you've got a new testing group, and maybe what are the psychosocial ramifications of using your tool? Are the testers hesitant? Are they on board? What do they get out of it?
Good question.
Right out of the gate saying you're going to lose your job. So what else?
Yeah, that is right. So AI in QA today, there's two levels of it. Well, there's three levels. One is AI washing, where it's just some tool that says they've got AI and they have none. And I must hear this from 8 out of 10 prospects. We tried this and we tried that. We couldn't find any AI to save our life. Then there's another set of tools. By the way, that's the most common, AI washing. Another set of tools that have patched on or thrown in some kind of copilot, easy to do, right? As you know. And what that does is it engages the test people, right? The testers, because they go, wow, I can use this Copilot thing. But it actually, in most cases, reduces productivity. And I could get into the exact reasons why if you'd like to. And there's a lot, by the way, this is happening in marketing. It's happening in dev. We've seen this. Sure. We've seen actual measurements where the people love it and they say, look, I'm using AI. Okay, but over the last 4 weeks, you slowed down. Yeah, but it's really cool because I can investigate all these things. Okay, I didn't need to do that. So give me one example. So when we're testing web applications, the way the web works is you can identify an actionable element many, many ways, visually, but also with a set of code that is underneath that element called locators or accessors, and there's parent-child relationship and accessor ID and XPath and all kinds of ways to find those elements, right? That's just part of the web. So a number of these automation vendors that added AI to the website figured out how to at least bolt on kind of Chat GPT or something like it next to that says, hey, let me give you a recommendation on a better locator than the one you chose. Except the problem is back in 2016, we invented machine learning that already not only chooses the best accessor without your input, it builds an entire accessor library and adds the visual. Like, I don't need the human input there. AI can do that work, right? Actually, basic machine learning is doing that work. I don't need the human's input at all. Now, the human can override it, but I don't need a copilot. And another copilot we've seen is Recorder. Works in this way, is that you use the application and we write the code, the test code, right? You just use it. We're writing the test code that's mimicking your actions. You fill out a form, we mimic that form. You click on something, we mimic it.
Overly literal too, right?
That's right. So then what some people did is they said, hey, instead of recording, you right next to it, we can put a copilot and you can type in this box. Instead of you clicking the blue box, it says you type in the box, click the blue box. Now the problem is it takes longer to type click the blue box than it does to move your mouse and click the freaking blue box. So again, this is an example of a use of a GPT kind of a thing like ChatGPT or Gemini or whatever that actually slows the user down. But if you were a tester, you go, look at the AI I'm using. Isn't this great? I can now type what I want instead of just move the mouse. But nothing's faster than moving the mouse. So those are the two.
Yeah,
we didn't get to number three, what we're doing. Yeah.
That your model is going in there directly and ignoring the UX folks and figuring out all the potential permutations and then trying to assess which ones are important. Yeah. Or is your point that we do leverage the humans actually interacting and showing us what the important, use cases are and navigating them, but then we kind of interpolate outside of that a little bit?
So there's two things that we do. There's two AI areas of the product. One is called AI script generation. We launched it back in 2017. What AI script generation does is it says, train me not on any of your specific use cases yet, but just walk through the application. Okay, literally all of the application, all the different states, et cetera, et cetera. And so there's a training session that can be an hour, it can be a day. It depends on the complexity of the application, right? And the idea there...
Not too different than you would train an employee or something.
Not any different than I'd train a manual tester sitting next to me before I sent them to do their job. Except I only have to train it once, because once it's gotten to every page state, anything that comes new, it will add to its knowledge base by itself, right? So I only have to do this one time. After you do that, we build essentially a digital twin of the application, and we generate hundreds or thousands of new test cases based on your business validations. So the other thing you put in what's called a validation workbench are the business outcomes that you expect. They could be data driven, they can be BDD level, right? They
so
can
maybe
be
give us an example with the JP Morgan case.
Okay, a simple example. If the customer puts in the wrong password, pop up a box that says wrong password. I'm giving you the most simple. Complex is if the client happens to be in New York State and they happen to be in this city, then make sure they don't have access to Y, right?
And so that's a rule that the human is giving you.
The human puts those into a workbench, and they come from the business rules that were laid out when the application was designed, right? So there's a set of business rules that are there, And so you take those business rules and you say, I'm going to give the business rules to the system. And they're basically in English, but sometimes there's some coding there if it's complex logic, right? As you can imagine, because English doesn't describe complex logic sometimes very well. So you do put in sets of business rules that say, test these, but don't test them one time. Test them from every possible permutation of a user flow you can.
And then when some back and forth, like is the bot working with the human to get the rules defined crisply?
Not really. You just put you literally place the rules into this validation workbench, and they're placed in there. Some of them are in plain English because there's these drop downs to form it in English, and some of them more complicated. You write it in JavaScript or get some help writing in JavaScript. So now you've got what we call our validations. Once those are there, the system by itself will begin to create brand new test cases that use those validations. And it will create thousands or even tens of thousands of every possible practical user permutation, user flow, that can leverage those validations and test those including data-driven ones, right?
Need help building a great chatbot, or perhaps help with computer vision, natural language processing, automated content creation, conversational understanding, time series forecasting, customer behavior analytics. Reach out to us at zyonix.com. That's XYONIX.com. Maybe we can help.
Let's dig in on the word practical, because I think this has been one of the Achilles heels for automated testing for 20 years or so. You can get automated testing, you can get automated code review stuff, and it generally generates a gigantic list of mostly inane garbage or utterly obvious things. So practical can mean utterly obvious, even whoever's building the thing finds out right away. But there's a big difference between that and a CTO jumping on your app and finding things that really matter.
Sure, that's right.
Nuanced and quirky. So what is the system doing to stack rank what it finds and
Great question.
Present them in a meaningful, impactful manner?
There are 3 levels of issues that the system will find across all of the practical ways a user would use the application. So we don't include going backwards and breaking things, right? It's like a user is using the application in the way it was designed, but there may be many, many, many pathways that lead to the same validation. So we may touch a logical validation 100 times, 300 times. Why? Because users will, right? From different angles, if you can imagine it that way. So there's 3 tiers of what we do. 1, if you fail a validation, it's your business logic. If you fail the business logic, that is probably a P0, P1. That is a serious issue because it says a user can fail that. I'll give you an example. We have a client that has an application that, depending on your role, it has fields that are not supposed to be editable under any circumstances. Uneditable, they're locked, right? So it's literally a locked record. You don't get to touch that. They test for this every time with 1 script. So literally that script runs and it always passes, it's fine. The first time they used AI script generation, it generated more than 200 tests of that same logic. You know what I'm going to say.
Presumably because there was some other state that led up to these things being editable.
That nobody had ever looked at before, but a user was able to, in dozens of cases, the AI was able to edit records that they did not have the authority to edit. And they never found this. And now they go back and they go, we don't know how many of those were edited over the last X years or when that bug even came in, because I'm telling my CEO with my 1 script that can't happen. And yet AI comes along and says, it happens 12% of the time, actually. You just never saw it.
Yeah. So in that case, I think, you're presenting a scenario where the business validation rules are maybe so important that no matter how the bot figures out how to get in there and exercise it, it's worth immediately addressing. But I think there's a lot of other scenarios where, let's say, maybe the ramifications aren't so severe, but the path that the bot comes up with is, let's say, an utterly impractical or like a non-important path because it just doesn't happen. One of the things I've always seen with this automated, like I've never actually seen automated testing done in a way.
Actually, we're the only people who AI generates test cases like this and scripts, period,
Right.
full stop, automatic,
Yeah,
no human involvement.
The reason I'm asking this is because I think most people who've used the automated, not AI kind of historical
Recorders.
yeah,
Recorder.
is that sure they find a ton of bugs, but they're usually like not important. So I'm really trying to understand like
I ha-
how do
so
you assess the importance of what the machine
So
finds?
Deep, I haven't seen that because the test cases that humans write that then get recorded in end-to-end testing are all important. It's not finding something that you don't want to find, or you would have never taken the time to write the test script for it. It's just not going to happen. There's no automation at the end-to-end level except for us that writes its own test cases, period. So it can't find things except for us. Your point is clear, and I will get to it. There's no other tool that does that. There's no other platform that does that. Now, if you're talking about source code, there's lots of that. We're going to scan your entire source code and finds all kinds of things. That is an unrelated field, right? We're already at the end-to-end testing where you've got a system that's connected to 22 backend systems.
Yeah, I mean, I guess what I'm getting at is you have a limited resource of humans and human machines that can address the actual fixes. I'm a CTO. I've been a CTO for 30 years. I've managed tons of teams. I've had incredibly large teams. A very, very common problem is the teams will wind up quickly with the test suite that over-identifies problems.
Sure, I get that.
And the team's forward momentum virtually stops because they run around trying to fix stuff that ultimately doesn't really move.
So there's three tiers of problems we find. One is logical validations that fail. You put in the validations, you said they were important, and it failed some percentage of the time. You can either allow that ticket to get filed in Jira, or you can say, I don't care about this anymore, don't do that anymore. The second thing it finds is 4xx, 5xx errors. To some people, those are the root cause of horrific problems later, and to other people, they don't care. They, again, get to ignore those if they want. They just check a box and say, don't find those anymore. And then the last ones are slow responses, meaning that even though we've just got a small number of users on this server, I'm getting responses that are taking over X seconds. And you get to set that. Is it 2 seconds? Is it 20 seconds? And you can decide, I don't care if it's slow. You get to decide what's important to you. Practically, here's what happens. The first time AI script generation runs, everyone in the team says, this can't be. You created thousands of tests, and these can't be real errors. But we give you the script to repeat the error. So then they run them, and they go, oh, they are real errors. And then they have to decide which of these are serious, like the one I gave you, the example I gave you, is a serious error. You do not want people changing records that are not allowed to change records, right? So that's serious under any circumstance. There's others that you go, yeah, the pop-up box doesn't come out, but I don't care about that. So then you eliminate that. Or you stick it in Jira and it's P5 or something like that. So the first time through, there's no question you're going to organize these results in some way in Jira or get rid of them or whatever. And then after that, they become your regression suite and they're fully automated. You have, on average, about 10 times the visibility or application coverage than you had before.
What do you think are the soft spots and the areas that you're trying to like perfect over time? Because
well, AI script generation, which I just described, creates brand new test cases, ignoring whatever your test cases are. By the way, they might overlap, but I just remember when we opened, I said, someone already has, who knows, 1,000 test cases written for that application that are manually done today, probably, right? So the second part of the product, the other part of the product, really third, is called Genie. And what Genie does is it leverages the knowledge from AI script generation, basically the digital twin of the application. It leverages that. We use right now 5 tuned transformers. I can take you through exactly how that works because I think you'll find it interesting. And what we attempt to do, and we do pretty well actually, is match what someone said in English in the test case to the actionable items on the page or on the page state. So I know which state I'm in, I know what's actionable there, and I know what they're requesting. And I can visually see the actual elements. I can visually see the entire representation of the page. I can see the code. I have to visually see elements because people describe things visually in these test cases. Mm-hmm. You know, click the tree. Well, I better see that it's a tree, right? And then what we do is we write that line of the test script automatically. So what Genie does is it automatically converts your existing test cases, no expansion,
into these scripts,
to code. That's it. Yeah, all by itself, no recorder, no human involvement. Go home for the night, come back in the morning, and they're all done.
So on your AI UX show, we like to cover three things. One is what you do, the other one is how you do it, and the last one is should you do it. So we've talked about the what quite a bit. So let's change directions a little bit and kind of focus a little bit more on the how. It sounds like, let's take the second application. So you go back and forth with some LLM, maybe you're using some of the more code-centric models, and you're creating some kind of mapping from whatever code has already been written by the humans into your sort of action scripts. Are you also coming out with business rules as well based on those scripts? Because that's probably in there too.
Are we talking about AI script generation, which we talked about first, or Genie, which we just talked about?
Well, why don't we start with the latter and then go to the former?
Okay, so Genie is doing one thing. You have 1,000 manual test cases, and I'm going to now automate those and get rid of the manual testers. They will run as your regression suite every time you ask it to. The first thing we have to do is interpret the test cases in a variety of industry formats. So we use an LLM with RAG to do that. So we have set up the format that we want, which is a very specific JSON format, JSON input format, that has a step number. It has only one action per step. It has a set of data that may be tied to that action. There could be multiple data inputs before the action is taken. So the action might be a submit button, for example, in a form field. And then it has any expected outputs, right? The equivalent of an assert. And those could be visual asserts or textual asserts or data asserts or whatever. They could be data driven. So we take generally whatever format someone's written these in and convert it to our format. They never see that, but that happens.
Understand that format a little bit because I want to understand what you're actually giving your model. So presumably there's like an entry, like if this is a web app, there's an entry URL to a page that you're looking at. Let's take
that'd be step one. Yeah, so it's actually go to that URL. Yes.
Okay, so then the action in that case is
it's called navigate to, actually. That is step number one.
So you'd have something like step one, navigate to with a URL. Step two might be like action, like fill out the form and
log in, right?
Or attempt to log in,
right? With some data, right.
Right. And then step three would be you
go to this place on the menu. Step four, fill out this other form. Step five, select the state that you're in. Insane. Step six, whatever, right?
The point is that it's textual. It gives you instructions that would make sense to a human and an LLM. And then the LLM in your world has all of the mechanical infrastructure to execute these things, meaning you've got the ability to go to a URL, you've got the ability to populate a form, you've got the ability to assess.
Let me answer that because it's not that simple. So the LLM I'm talking about right now, and these are all privatized models, right? These are all open source models that we privatized and either trained in a specific way or set them with RAG to work in a certain way for us, and or given them a whole set of guideposts, if you will. So let me say the first LLM is doing nothing but leveraging RAG to transfer the test case that came in, maybe in Excel, maybe in a CSV, maybe in a Word document, maybe in whatever, transfer it to our JSON. They won't see that, but we need it transferred to something that we understand in a very specific format, right? That's all that happened there. We didn't change their language. We didn't do anything. We just moved it from this to that. Because people sometimes will put like 5 steps in one step. Step 2, do these 5 things. We can't do that, right? Because we need a step to go to a line of code ultimately. So all that breaks down into 5 steps instead of 1, for example. So all of that is done in that first LLM. Now I have a JSON format that is my format. It's a step number. It is an action. It is maybe some data input. And it's finally, what do you want to validate happened at the end of this step? Because most of these say, what's the expected output? The expected output is, I see the following thing on the page, right? Whatever it is. So we have to look for that expected output. The other thing I've input here is that digital twin. And we probably don't have enough time to talk a lot about a digital twin, but just that is an offline, if you will, static image of every state of the application and where those states connect to based on actions in each state. I know that's a lot of words, and they are big. They can be 50 gigabytes. It has every actionable element visual. It has all the code, sort of the locators that go underneath that, and it has a page visual for every page state. Okay, so all of that's stored.
And what's the point of this? Like, why can't the system just interact directly with the system?
That's a good question, because we need to go substantially faster than humans. And to go substantially faster than humans, I'd have to go faster than an application. An application can only respond, call it 3 seconds of state, 2 seconds of state, 5 seconds of state, whatever it is, right? But what happens if I need to execute in parallel without actually changing the application state, but I know where I would have gone, and I want to understand how I go from step 1 all the way to step 46 and understand that whole string, and I need to do it in 100 milliseconds. I can't do it with a live application. So we patented this concept some years ago of a digital twin of an application, which I can now navigate instantaneously, and I can go back. I can go backwards and look at things. I can do these in parallel.
That doesn't make sense to me. I mean, if you want it to be faster, then that seems like an opportunity for a performance tuning application, because the app builder, if there's a bottleneck in a particular part of their app, they should address it. If there's a problem in running your users in parallel at a throughput level that they, need to support anyway, then they should address it.
No, because their application is what it is, right? Someone operating a recorder can create a script no faster than 1x application speed. If they could click infinitely fast, which they can't, so practically it's 2x application speed, right? If I want to replace the recorder, ultimately I have to go faster than 1x application speed. And I can't start over all the time. I may need to evaluate a set of steps back and forth, right? For a whole set of reasons. And I may need to interrogate something I did before to understand what I'm doing next in writing the scripts, not in testing anything here, just writing scripts. So if I have an offline version that responds instantaneously and doesn't affect the states if I go backwards, well, then I have the perfect model to generate scripts from. It's no different than doing a digital twin of something else. There's value in having, say, a digital twin of the Earth, because I can simulate things that I couldn't do in the actual Earth. That's an obvious one, but this is the reason
I think you're saying, if I understand you right, you're saying that this type of testing can be a burden on the live system. And so you're trying to offload.
No, it has nothing to do with the burden on the live system. It has to do with the fact that I am trying to do things that would be very hard and long and arduous on the live system. And I only have to do it once. I've got to generate these regression scripts once. And once they're done, they're going to use them on that application for the next, who knows, year, 2 years,
like
5
you're
years.
building an offline caching system, basically.
Yeah, there you go. That allows me to interact with it without breaking
You're
it.
going to keep doing the same thing over and over again, and you don't need to necessarily use the live. Okay, that makes sense.
They will eventually use the scripts that are generated against their live application. But I'm generating them using a digital twin, which is the only practical way to do it when you get into the idiosyncrasies of what has to happen inside that.
Presumably, some of those path flows, expire just like a cache because some team inside deployed some new feature or something.
Yeah, and then you can retrain it, learn the new behavior, and generate new scripts. But otherwise, you've got your regression suite that yesterday was manual and today is now automated, and it's an exact replication of the manual tests, right? And the reason that was able to happen at a speed of 100 scripts an hour or faster, depending on how many GPUs you deploy, is because I'm not doing it with the actual application. I can do it with a digital twin and interrogate the heck out of that digital twin and never impact its fixed states, right?
Yeah, I guess that makes sense because you're doing a ton of repeat operations and
yes,
to figure out how to construct these scripts.
That's right. That's exactly right.
Have data, have a hypothesis on some high-value insights that, if extracted automatically, could transform your business? Not sure how to proceed? Bounce your ideas off one of our data scientists with a free consult. Reach out at Xionics.com. You'll talk to an expert, not a salesperson.
So now I've got my JSON and I've got my digital twin, and that digital twin has all this information. So now what I need to do, now I have to caption my actionable elements. I need to convert the actionable elements to some kind of English that someone might have said, right? So I need to understand how that might map. So we look at lots of captions, a blue button, it says submit. Also, I want to know where it is on the page. So now I have to look at the entire page. I have to build a page model and say that blue button happens to be in the lower right corner. Right? So I want to get all of that information back to text. And now finally, I have some interesting information. I've got captioned elements. I have got essentially a captioned page. I have got everything in JSON, and now I can present this all to an LLM in the following way. I can say, I have a line of text that says, click the blue button. What should I do on this page out of all of the actions? Now, the truth is we don't give it all the actions because we wouldn't get the best results and it'd be slow for the LLM, even with a wide aperture. So, of course, we've already...
we kind of understand, right? Because we've
already picked the top 3 or 4.
A bunch of folks have this concept of steering the browser and, doing it via text.
Yeah. So far, it's very hard to do that and get better than 70% consistency. But in QA, I have to be 100%. So follow my logic. We've done all of this. We are now scoring all of the actions on the page and saying, what is the highest scoring one? Okay. How well does that map to what they said versus everything else I could do on the page? And then what do? I feed that, and it's a state and an element ID, an internal element ID. So I have, state 4, element ID 3, and I have my digital twin. So what happens is I feed that to a code generator that we built. And the code generator says, I go to the digital twin, and what do I see? I know exactly that state, that actionable item, right, that element. And under that element, I see all the code. And I build out the code based on all of the locators and it's JavaScript.
That page. The code
the code to execute that element on that page through a code generator, which looks a little bit like a compiler in a way, because I've given it very little information. But between that and the digital twin, I have all I need. I reconstruct perfect code, not a guess it code, and that is ready to run. And we do that step by step by step, but we do it fast. It's, 10,000 steps in an hour or so on one A100.
That executable code to execute your actions on a given page, is that exposed to the users if they need?
Yep, that drops out as scripts, and you can see them in what we call designer script English, or you can see them in JavaScript, which is what's underneath the English, right? And it builds out an accessor library. Why did I build an accessor library? Let's say there's 20 ways I can find that element. On your next build, some of those will go away, some of them will change. We will use the entire library to say, I believe this is the element that you still meant, and keep going, right? So it self-heals the runs as they run on top of it.
Okay, I think we've covered the what. I think we've covered the how. I feel like I have a decent understanding. Let's go to the should, which is always a thornier topic. And I don't mean that necessarily like we have to pick on your application, but I like to bring guests up a level. But in your case, I think you've said some bold claims, and let's kind of dig into them. So one of the claims you said is if you're successful, there will be no QA team or something. Walk me through that a little bit. Is that like kind of a hyperbolic statement, or is there a trajectory there?
Here's what I'd say. When we look at QA teams around the world, call it 3 million people, there are maybe 10% of those are senior strategic architects, evaluators, et cetera, right? Those are not going anywhere. In fact, we may need more because, as you pointed out,
because you've pointed out quite a bit of configuration and quite a bit of thought that you have to get from the people who actually are looking at these applications.
And those are going to be the robot overlords. Like any other AI, the new skill set is, how do I train this AI and how do I get the most out of it? Not how do I sit there and write scripts or manually test. So the other 80 to 90% are scripters and manual testers. AI eliminates those jobs, period, full stop. And we already can do that today. So this isn't the future. Now, should we was your question. I will tell you there's not a CIO/CFO, and sometimes they're locked at the hip a little bit, that is going to pay for AI going forward unless they find the savings somewhere else. Money doesn't grow on trees in an enterprise. It could be that it's customer facing and it improved our revenue, right? Improved our advertising, but for back-end systems, nobody's going to pay for Devin if you cannot measure the improvement in coding in some way, or a reduction in hiring new hires that you don't need anymore. And the same is true here.
But let's jump out and look at this from a societal standpoint a little bit. In your argument, you just eliminated 90% of jobs in a particular scenario. And in your argument, the 10% that remained were the sole strategic architects that somehow had to get there. They happened to be the ones who kind of came up through this process of like learning things, figuring it out, etc. Right. So what happens in a new world where some kid just graduates with a computer science degree or whatever, needs to enter into the workforce? they're never going to go through all these steps. Granted, they could be a dev or something else, but a similar kind of path is happening on the dev front.
It is.
There's people making kind of really significant claims saying things like every knowledge worker is going to be gone. It feels a bit extreme to me. It feels to me like with every new tech, we're going to invent another five new problems. And
I think
and
that's
so
right.
what are those other five new
Well,
problems that
okay.
come out? You know,
So,
and
look, everyone is seeing already the collapse of the market for new grad coders. The market to hire, QA aside, the market to hire new coders went from hot 2 years ago to almost dead now. I mean, we've never seen this kind of shedding of I don't have a need for an entry level person. This is also happening in customer support and call centers, which are being wholesale eliminated across the world. And I think tier one customer support will be completely eliminated in terms of humans over the next 2 or 3 years because AI virtual assistants, well, you mentioned it, right? I was the inventor of the darn thing. Arguably, I kicked that off in the late 90s. And even then we said, if this moves forward in the way we think it will eliminate customer support jobs because you won't need to do that. They're easy. I can easily train you on these FAQs and it'll do a better job than the humans. It just is. However, we are creating new jobs to train AI and coordinate AI and create guardrails on AI and manage the AI. And mostly the jobs that are going to be around in those fields are going to be much more around being the robot overlord because the robot, so to speak, can do a lot of the basic tasks we've been throwing at humans. It just is.
The challenge I have with this new world we're building, it feels like we're sort of underestimating the role or the need for humans to actually understand what they're overlording. And it feels like if we follow through with this sort of light approach, this generation might be okay. We have a whole generation of people that actually know what they're doing, and we could just mooch on to the senior staff. But it seems like at some point we wind up with a bunch of Homer Simpsons regulating the nuclear power industry, and they're clueless. And it seems to me like it's like you have to come up with a way for humans to actually learn and know the things that they're supposedly overlording.
Maybe that changes our university education because we don't need kids coming out of university that can code in Python. What we need is kids that know how to leverage the AI tools to generate really thoughtful architectures, right? Now, we have seen this before, Deep, and I use this example a lot. If you were in finance in the late 80s and Excel showed up, before Excel, you were doing a lot of math and you were doing pencils and ledger books and all of that. Literally all those jobs went away. Yet we employ more people in finance today than we did then, and they're all strategic. Nobody does math. You don't need to do math. Math was solved. So we've seen this kind of cycle with math. We just haven't seen it broadly across the knowledge worker space, but we're seeing it now.
The problem with that argument is that even that feels ephemeral. Like if I look at the reasoning level of O3, let alone the O1 models, they're already smarter than the vast majority of us. They already reason better than the vast majority of us. So it just seems like, sure, that's our current popular argument that everyone in AI is using, like, oh, we're going to have the humans overloading, and we probably always will for stuff like medicine. There'll probably be a radiologist like training some models and like inspecting stuff where it's obvious. But at some point, when the humans are wrong, when the models outperforming the humans consecutively, we're going to start undoing those things as a society. It seems to me like we got to come up with something for humans to do. At least in the physical world, I think it's going to be a while before the bots are refinishing my basement. But it's not going to be that long,
It's not going to be that long. We may be 5 years away from humanoid robots being in our home doing some cooking and cleaning. It's reasonable.
And there's a cost reality there. It's 45 grand for
That's right.
a dog that runs around construction sites. I mean, at that kind of cost point, it starts shifting things. Moore's law, those costs will drop. But it seems to me we're seeing a radical restructure? Like if your product is, well, first of all, I did want to ask you, like, what's the state of your product today? Like
In production, doing millions of tests a day.
and
So
how many like customers and like what does your growth trajectory and all that stuff look like?
growth trajectory is good. We don't release the number of customers, but a lot of our customers are very large. They have hundreds or thousands of applications. So
Right.
we tend to not work with clients who have 2 applications, right? We tend to work with companies who are large and can expand. And so that's been much more of a focus because once they have trained some robot overlords, they go, well, I can do 10 applications, then I can do 20, I can do 50, I can do 100, I can do 1,000, right?
Are you
And
seeing that though yet, or are you
Yeah.
still in the earlier stages?
No, we're seeing that. You know, the company's been around more than a decade, and 7 years of that was just R&D. This was a really, really, really heavy lift. It's a couple million lines of code. Deep, this isn't something, although 4 or 5 companies tried to do this isn't something that 2 kids out of YC do in a weekend. In fact, they're quite taken aback when they find out how hard it is to get AI to write test cases by itself, write scripts by itself that all run. An applied AI that takes more knowledge about how applications are built and run than it does about the AI, if that makes sense.
It does make sense, and we see that in all kinds of, I mean, that's the story across the board with the LLMs. You flirt with the web interface and you're wowed and you cut and paste, but like getting it all to work end to end automated takes
Very hard.
takes a lot. It's like a different order of magnitude of effort.
Yep.
So let's say, you guys are succeeding, there's other companies like you succeeding. That's not a like 10-year story. Like if what you're saying is true and companies internally are going from 1 or 2 products to like 10 or 20 or 100 or 1,000, then that'll probably just sweep across the entire industry within the next few years.
I think it will. I think that probably 90% of the test automation tool vendors in my industry are truly AI washing. The rest have a little bolt-on chat kind of thing.
Yeah.
No one else is doing it. Now, we have 7 patents, but no one else is generating tests automatically for people yet, other than us. They will.
What do you think are the core ethical quandary there, or have you sort of accepted that this is this massive societal shift? I'm playing a smaller role and like, I'm not going to worry about it.
I think the train left the station when we figured out deep learning in 2012, right? And transformers came out of that and LLMs came out of that. And once the train left the station, we were all on it whether we wanted to be or not. Like there's no choice, right? And so if I don't do this, it's okay, another company will. But we can't sit here deep and say, oh, there'll still be manual testers 5 years from now. No. No, I mean, whether I solve that or someone else has solved, it's solvable with a lot of code and a lot of effort, but it's solvable with the technologies we have today.
Software's a little different, right? Like all of us since the first day we worked in this industry have been automating ourselves out of jobs since the beginning.
We have.
It is all we do pretty much. And so it makes sense to you and I that this industry adopts things immediately, grabs it, runs with it. But it still leaves the question, like the suburbs and cities of the Western world are populated by people who pay their mortgages that have benefited from the last 30-year tech boom.
Right.
And what is going to happen to that engine, and is it really replaced by something else?
Let's take a look at a different job, not in tech, right? Insurance claims adjuster, of which there are, I don't know, 250,000 working in this country or something. Huge numbers, right? Huge.
Yeah.
The insurance companies have thousands and thousands of people that do nothing but evaluate what happened to your car, figure out where to take it, figure out if they're going to pay for it, figure out blah, 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 right? Already we have the most advanced insurance companies saying, take a picture from 5 angles with your phone, send it in, and at first, of course, there's human evaluators, but you know what I'm saying here. We don't actually need humans doing that. You and I know all the technology that we need to do that automatically and literally ACH the money to you in 3 minutes already exists. All of it.
Correct.
And there is no question
do it more accurately and less biasedly, I would argue.
More accurate, less biased. And some people say, well, people will cheat. First of all, people already cheat, and that's a legal problem, right? And second, it's more likely the AI will catch that than a human. And third, you can go to jail for it. So the overall insurance costs come way down when you take those 250,000 people out of that job. Those are regular jobs in regular little towns all over America that will go away. That's not an arguable, because if you know AI and you know deep learning, And if someone came to you and someone comes to you and your team and says, this is what I want to do, build the system, you already know how to build this.
Yes, I do. And
Yes, so do I.
But it still leaves the question. I mean, I get we're going to always have a need for the top 0.5% of PhD students, but like, what happens to the other majority of people who are just maybe sort of bright, but not super bright? They're like on the Gaussian curve, they're in the center. We don't need their level of reasoning anymore. What is humanity doing? Bartenders, waitresses, we're going to need them because nobody wants to get a drink from a robot.
That's right. We need more people helping old people in nursing homes and. What I think is that every technology change that's come around displaced lots of people but gave them new opportunity. Obviously, the farming example is one of the best ones where most of the country worked in farming and now 1% works in farming and produces more food because of automation. Right? This is not new. But what's new is every time the automation comes around, people go, what are people going to do? And somehow we've created more jobs. But I think the reason we create more jobs is that by leveraging this automation, we are driving down the cost of producing either products, goods, or services. And when we drive down the cost, we drive up the demand, which makes the companies larger, which means they need more people for other things that machines really shouldn't be doing, can't be doing, humans don't want them to do, et cetera, et cetera.
So what do you think those other things are?
Well, there's obviously the robot overlording, right? I think there's going to be people in sales. There's going to be people, a lot of marketing is going to be done automated. This is a great talk about marketing, right? We still have people deciding what to do and how to do it, but very soon you will be able to go to Facebook and say, here are my USPs, create my ads, change my ads every hour if you need to, do whatever you need to do within this set of rules and generate them automatically with AI. And they're cutting out the advertising agency completely. So you have a WPP that's a multi-billion-dollar advertising agency. Why do I need them? AI can not only create better ads, it'll change them every hour. You couldn't possibly keep up. So there are some of these things that go away. At the same time, by driving down the cost of marketing, I'm able to drive down the cost of goods and services, which gets it to more people, which means there's higher demand. I've got a bigger company, so I need more people in some of the other roles. Sales, marketing, some of the HR roles are certainly not going to go away. There's executive roles. You need more. If the company's twice the size, you might end up with twice as many executives. But doers, like sitting in, it's going to be less. We've been automating car factories since 1961. First robot, GM, 1961. Here we are 6 decades later. And a GM employs more people than they've ever employed. They also employ more robots than they've ever employed. The robots have driven the cost of getting a vehicle down to something affordable for middle America. And without that, a car would be 10 times the cost, right? So this automation was required to drive up the demand, which increased jobs.
I think my optimistic side agrees with you. I think my optimistic side also believes that humans have an insatiable ability to reinvent what they care about. You know, like 40 years ago, if you wanted, like, let's take soap. 40 years ago, you wanted soap, you bought a Dove bar of soap. In my neighborhood in Seattle, this sounds bizarre, but soap is probably like the ultimate status indicator. You walk into somebody's bathroom, and if they have Dove, you're like, oh, they must be poor or a college student. But otherwise, you know, it'll be some fancy artisanal hoo-ha.
Right, of course. In a bottle, and it comes out.
Yeah, maybe in a bottle, maybe like not my wife. She wants everything like it's like in this fancy organic wrap packaging. It comes from
India,
I know all this stuff, right? So humans have this like ability to redefine, like, so the whole artisanal movement, you know, people don't employs millions of people that had no employment a few years ago. Yeah. So I think like all of that's right. Also, there's certain things that are boundless, right? Like the ability to just get humans to live forever, you know, is an incremental step, but a step-by-step process, but people will put whatever they need to in healthcare to improve health. So if you saved them $200 a month on their car insurance, you know, and they can throw it into some alternative wellness therapy, they'll probably do it. They'll probably take a yoga class. They'll probably...
That's right. And doctors' offices are certainly going to be augmented by AI, and they should be. Because the AI is far better than a doctor being up to date. Like, these are obvious things. I think we'll see how it pans out, but I'll say this in my field is, if you're watching this and or listening, and you are in the software QA field, you want to learn the technologies that Appvance has, or if you can find it elsewhere, because you want to be the robot overlord. There will be people that will run that operation, and they will be experts on the AI. And those that aren't are certainly eliminated, right? That's the bifurcation. And I see both, and I see people today across not just our industry in QA, but others sabotaging. You brought this up right up front. How do the workers feel?
I see this actually because we're
They're sabotaging it.
Help folks, and a lot of times projects are positioned in a way that the people who are going to be affected by the AI are, they're not stoked about it, and I get it, and that's exactly why you brought up the co-piloting approach. That's why the co-piloting approach is taking off, is specifically because you're kind of getting people on board, and it's like a Faustian bargain on some level where we all accept. I mean, we're all in this. It's not like I don't use LLMs. I use them probably, 400 times a day or something.
Me too. Me too,
so,
of course.
So, I mean, I do want to push a little bit on the potential negative future, because I think there's a lot of things that policymakers and others must address. And I think largely with the internet, they kind of failed to think things ahead. 30 years ago, when this stuff started evolving, the legal world didn't catch up even till now. They're still catching up.
That's right.
I mean, I think there's going to be a lot of pain in the very, very near future. I mean, we really run the risk of a deep, deep recession where people that have maybe been out of work for at most 6 months or 9 months in the past are looking at 2, 4, 5, 10 years, and career changes and shifts. That seems inevitable to me. I don't see how a mid-tier, not so great at their job, but not horrible at it person keeps in that career path in this world.
Well,
you got to be in the top.
Deep, if you in your company have a low end or a mid-tier person that isn't really great at what they do, are you really keeping them anyway?
Well, we're too small to get them in the first place. We only have great people, because I don't have
right. But you see my point is, these are people who have always been on the edge, and they've probably gone job to job.
Bar. My point's not that we haven't always had them; it's that we raised that bar a lot.
Right, that's fair.
That bar a lot, right?
And what are those people going to do?
Have a hard time getting a CS job? Probably not. But I'm seeing kids, with a master's degree in CS, in AI, from great universities, looking for months and months. And I'm like, wow.
So the answer is then, there's 8 million jobs open right now, give or take, in the U.S. And you go, where are they? Well, let's start with nursing, tons. Yeah. Let's start with plumbing, electrician, HVAC, taking care of old people in nursing homes. I know a lot of people, I don't want to do that. And I'm not trying to say that you should or shouldn't. I'm trying to say there are going to be openings all over the place, and they're not necessarily where they used to be.
Yeah, I think that's right. And I think we actually have an opportunity to push humanity into fields that have higher human touch and human impact. This has been an awesome episode. Thanks so much for coming on the show. Yeah. Really enjoyed having you. So
thank you.
That's all for this episode. I'm Deep Dhillon, your host, saying check back soon for your next AI injection. In the meantime, if you need help injecting AI into your business or project, reach out to us at xionyx.com. That's XYONIX.com. Whether it's text, audio, video, or other business data, we help all kinds of organizations like yours automatically find and operationalize transformative insights.